This video is on simplifying radicals. In this video, we're going to take a look at how to simplify square roots that contain variables. So, my first radical is a cubed. We know that when we're simplifying square roots with numbers, we want to find perfect squares. When we're simplifying square roots with variables, we want our exponents to divide by 2. Because I'm taking the square root. If I was taking the cube root, which there are additional videos available, you would be looking to divide your exponents by 3. So just like when I simplify with numbers, I'm going to split it into 2 pieces, a perfect radical on the left and a non-perfect radical on the right. Any variable that has an exponent that's divisible by 2 is considered a perfect square. So a to the third. My exponent of 3 does not divide by 2, so I need to break it down. So I'm going to count backwards and see when I find something that's divisible by 2. So 1 less than 3 is 2. That works. It's divisible by 2, so I get an a to the second power. But because I'm breaking it down, I can't just have an a to the second power. I still have another a left over, because remember, that's really a to the first. So now, my square root of a squared is a, and my non-perfect radical stays. So the square root of a cubed, simplified, is a radical a. Let's take a look at our example on the right. The square root of 8x to the fifth, breaking it into 2 pieces once again, a perfect and a non-perfect. I'm going to deal with my number first. Remember that we're looking for perfect squares, 1, 4, 9, 16, 25, and so on. So what number divides in evenly to 8? I have a 4, and it's 4 times 2. So once I have my numbers, I then move on to my letters. X to the fifth. Remember, for something to be a perfect square, as a variable, it has to have an even exponent, or it has to be divisible by 2. 5 is not divisible by 2, so I need to break it into pieces. So I'm going to go 1 less, x to the fourth. That works. So that's my perfect square. But remember, there's still an x left over in my non-perfect radical. Now I'm going to simplify that perfect radical on the left. The square root of 4 is 2. The square root of x to the fourth, x squared, keeping my non-perfect radical on the right. Let's take a look at 2 more examples. On the left, the square root of 54, a to the 8th, b to the 5th. 2 pieces, once again, a perfect and a non-perfect. For my numbers, 54, I'm looking for a perfect square that goes in evenly. This breaks down to radical 9 and radical 6. With my variables, I want them to be divisible by 2, the exponents. So I take a look, a to the 8th. 8 is divisible by 2, which means it's a perfect square. So I have a to the 8th on the left, and I don't need to break it down, so there's nothing on the right. I move on to the b's, b to the 5th. 5 is not divisible by 2, so I need to break it down. This is going to be broken into b to the 4th and b. So my left radical, my perfect radical, is going to be simplified. Square root of 9 is 3. Square root of a to the 8th is a to the 4th. The square root of b to the 4th, b squared. My non-perfect radical on the right stays, square root of 6b. And our last example, same thing here. I'm breaking it down into a perfect and a non-perfect, except this time I have that 3 on the outside. 50 is going to get broken into 25 and 2. With my exponents, I want them to divide by 2. 7 does not divide by 2, so I need to break it down. b to the 6th and b, because 6 is divisible by 2. So I still have this 3 on the outside, and now I'm going to simplify my perfect radical. Square root of 25 is 5. Square root of b to the 6th is b to the 3rd. And then I have my non-perfect radical, 2b. Last step, multiply those 2 pieces together. 3 times 5b cubed gives us 15b cubed, and I have the square root of 2b still there.